Now, even though we haven't started talking about logarithms yet, I think this is a good time to look at graphing log functions, because remember what I said at the very first lecture this week. Log functions are the inverse of an exponential function. Remember what we said about inverse functions. X and Y switch places. So we've been working on exponential functions this week. You know the points on an exponential function graph. Why don't you write them down in your notes? So you've got those notes or those points there. And remember, this is where A is the base of our exponential function. So if we know the 3 points on our exponential function graph, and you should have them memorized by now, all we have to do is switch X and Y. Why don't you write down the points for a log function graph? Here are the 3 points on our log function graph. And remember, X and Y switch places. So instead of a horizontal asymptote where Y equals 0, now we're going to say that X equals 0. And this means we have a vertical asymptote. So here I'm asking you to graph 2 functions, an exponential function and a log function. Let me point out the base of the exponential function is the same as the base of the log function. The log function base is always written right next to the log a little bit lower. And we say that this is log base 2 of x. So first of all, can you write down the points on the f of x and then graph that function? So we have our exponential function graphed. Let's think about what we said about inverse function graphs again. X and Y switch places, and the graphs reflect across the line y equals x. Find the points for the g of x and graph that function. I hope your graph looks like this. Let's check to see if they are reflecting across y equals x. Remember, y equals x is going to go straight through the origin, straight through 1, 1, 2, 2. And I can see that each of these points is an equal distance from my line y equals x. Let's try another one.